Okay, now if everybody's ready, I'm just going to delete my things. Sorry, guys. Sorry. So sorry about that. Yeah, I'm back. Yeah. And I'm having difficulty deleting my. There you go. Oh, great. Okay. I will now try my best to explain something which is totally new, and it will feel a bit heavy. Okay. Feels weird and heavy. Totally new. But please bear with me. Give me a random one-digit number, Eben.
5.
5. Okay, these are random. Okay, now similarly, I'll just use the 5 like that. Okay. And then I'll use this one, never mind. I'll use these two first. Right. Now, the topic is like this. It's called calculus, whatever that means. And calculus is different, divided into two things, the differentiation or, I'm so sorry. Or they call it derivative, both which doesn't make a lot of sense. Okay, they are not common words and they mean nothing to us right now. Okay, the other one is called integration. All right, this is also not the integration that you usually understand. It's not. They mean totally different things. So they might as well mean nothing right now. The only I want to mention is like this: they are the reverse of each other. That is the most important thing. I'm communicating to you that the topic calculus consists of two new things, but they are a reverse of each other. So they are very tightly linked. Your teacher teach them separately for the love of this world. I do not know why. It is so easy to teach them together. I'm teaching them together to make your load much lighter, much easier to understand. One more time, whatever differentiation or derivative means, it is just the reverse of integration, whatever that means. Now the symbols. The symbols are, strangely speaking, d something of dx, whatever that means. That's a symbol. And the symbol of integration is this weird worm, integration of something dx also. All these are super new and we'll just have to get used to them. Now, for the sake of brevity, this is only done for our tuition, okay? I've never seen teachers do it this way, but I will do it that way. In this topic, whenever I go down, I actually mean differentiation or integration. And whenever I go up, I actually mean that's the integration, whatever those things mean. So very easy. If I keep going down, I keep differentiating. If I keep going up, I keep integrating whatever that is. Okay. Now I'm going to do my first differentiation. Symbolizes informally by an arrow down. This is not a formal symbol. It's just between you and me. The X is still there. Please observe there are three things here. 1, 2, and 3. Sorry, this is the first guy. See? The first guy I handle is the X. The X never changed. So thankfully. The second guy is this. I will handle the second guy. It's actually very easy. It's just -1. Matthew just confirmed 5 minus 1 is
4.
4. And there you go. That's the second thing. You do not know why I do this, but what I did is rather simple. Now, let me correct myself a bit. The first guy is actually 2x. So actually nothing happened with the 2x. Okay, nothing happens. The third guy is something here. This is the second one. The third guy is, strangely speaking, 4 times. The 4 exists here, and then the 4 also here. And you have absolutely no idea why I did all this. But I only do 3 things. Let me repeat that one more time. I take the 2x and keep it 2x. I take the 5, make it 4, minus 1. And then for some reason, I put the 4 again on the front and I 4 times everything. As a result, the final thing will be 8x power 4. This gives you an illusion that the 2 changes. The 2 changes. The 2 never change. The 2 is always there. It's just that 4 times everything becomes 8. One more time. This gives you an illusion that the 2 changes. The 2 did not. Just stay there and just times 4. That is way easier. I notice some teachers don't emphasize this. This is very important as things get more complicated. Now, I'm not claiming that you will understand what I'm doing, but what I'm doing is easy to follow. Let me just confirm this one more time. Anu, can you follow?
Yes.
Ariel and Eben?
I guess. I just don't know why. Yeah,
Correct. Correct. But I will give you the why soon enough. I promise. Promise. Right now, it's just a matter of easy to follow on. Matthew?
Yes.
Okay. Nicholas, and did I miss anything? No, I don't think. Nicholas? Is this easy to follow, at least lah? Nicholas, you're muted, I think. Yeah, okay.
Oh,
Nicholas?
uh,
Are you okay, Nicholas?
no, like where the 4 come from?
One more time. The 4 simply comes for, oh, this guy is 4. So for some strange reason, I also put the 4 here. That's all. Totally does not make sense. I understand. Totally does not make sense. The 4 comes from there. Good question. Because none of this makes sense. Can Nicholas?
Okay.
Right. Again, I am doing the same thing, right? I'm doing the same thing to this guy next to me, right? So again, help me out, Matthew. What happens to the 2x?
Stays there.
There, 2x. Great. What happens to 1 over 5? This is the second thing, right? Matthew, still the same?
-1,
Which is?
like, wait, 4 over 5.
Minus 4 over 5, you mean?
Yeah, my bad.
Okay. Minus 4 over 5. Again, does not make sense, but it's minus 1 still. So second one. The third one, what do I do, Matthew? The third thing?
You multiply it by -4 over 5.
Correct. Negative 4 over 5, like that, in front. And that will be my third thing to do. So I'm doing something very consistent, even though the function seems very weird. As a final result, this will become minus 8 over 5, x power minus 4 over 5. Whatever this means, what I'm doing is something consistent, I hope. Okay, still doesn't make sense, I admit. Can? So far, so good, guys. Okay, I'm going to demonstrate one more thing. Okay? So just take this one. At this point, this is not a proper note, so you don't worry about it too much. Okay, you don't worry about just scribble because you want to follow me. Okay, don't worry about it too much. Now I give you a minus power 3 here, and then I give you, I don't know, a 4 there, right? I'm gonna invite Eben to do it with me. What's the first thing I do, Eben?
Keep the 4x.
There you go. Okay, I'm differentiating, and then what the second thing I do?
-1.
Right, minus 4, and the third thing I do?
Times 2 of the power.
No, not times 2. No. Take the power and just times minus
times
1.
4.
Times, not just 4, but minus 4. Okay. As a final result, what would be what would it be, Abid?
Minus 16.
X to the power of minus 4. Okay. All right. Okay. Now, guys, your teacher, some teacher, sorry, not your teacher, some teacher will start by doing the front guy first. They will insist that you should think about the 8 first. I insist that's the last thing to do. It makes it very difficult to do it if you do that first. It's just much easier to start with what never changes. One more time. What never changes. What changes very easily, which is the second guy. And then what follows after the second guy. Again, most teachers do not emphasize this or will just do it however you wish for it. I do not wish for you to do it that way. I wish for you to do it my way. First, second, and third. It will make things much faster, much easier when things are hard. This is nothing. This is still nothing. Okay, I hope that is clear, yeah? Now, I will show you a few...
Teacher,
yes, Nicholas?
in the first part, you said 5 become 4, then 4 times. And suddenly, second part become negative 4, 5. Then now become negative 4.
One more time. What is the third thing, right? The third thing is I take the power and just multiply in front. As weird as that sounds, that's all I did. Right?
Mhm.
That's it, look.
I don't get it.
I'm not saying that you get it. I'm saying that can you follow now?
No.
One more time. I'm taking the power. What is the power?
Negative 3.
Sorry, which one are you talking about? The second guy or third guy?
Both.
So second guy first, right? Sorry, are you talking about this one? Or are you talking about this one?
Okay, second guy is 1/5.
So minus 1 is negative 4 over 5, right?
Minus 1.
5 minus 1 equals to 4, correct?
Yeah.
So 1/5 minus 1 is?
Minus 4, 5.
Okay, will this be okay?
Okay.
Right? And then I take the negative 4 over 5 and multiply in front. That's the third thing I do. Now, will this be okay?
Minus 1. Why minus 1?
I'm not explaining the why, Nicholas. Hold your why first. Everybody's holding their why right now. I promise to explain later. But I am doing exactly negative 1 every time. I am doing that. Follow me for now. Can you accept that?
Okay.
Right? Now, I'll show you a few other examples. They look easy, but hopefully you get it. Now, x. 3x lah, right? We are differentiating 3x, which looks much simpler than what is happening just now, right? So Ariel, please differentiate 3x for us. What's the first thing to do?
Write down 3x.
Right, that's the first thing to do. The first thing is, oh, this guy never changed, right? What is the second thing to do?
Like write down like minus 1.
So the power is minus 1. But what is the original power, ladies and gentlemen? What is the original power? What is the original power here?
1.
1.
1. Therefore, 1 minus 1 is
0.
0.
3.
That is why you should write.
Okay.
Okay? That is why you should write. That be okay. Sorry, let me take a drink. Now, I apologize, yeah. I made a mistake, right? I made a mistake. Apologize. I have to correct my third step. I have to correct my third step. The third step is slightly more confusing, right? This shouldn't be 4. This should be 5.
Oh.
No explanation given. But oh my goodness, right? Sorry, I'm not mastering GoodNote, right? Instead of 5, instead of 4, it should be the original power. Right? I make a mistake. Sorry, I make a mistake so early. This shouldn't be 1 minus 4 over 5. This should be 1 over 5. My apologies. This shouldn't be minus 4. This should be the original power minus 3. Okay. Now, for this one, the original power will be 1. 1 times 3 power x to the power of 0. Now, Ariel, let's complete this. 1 times 3x to the power of 0. What is this complicated thing actually is? 1 times 3x to the power of 0. What is that? Now, if you remember, Ariel and everybody else, what is
everything
x to
is
the
just
power of
like
0?
1.
Correct.
Yeah.
Whatever power 0 is 1, right? Whatever it is. So your in this is being tested here, right? Simple in this, but it is being tested. So in the end, this complicated thing becomes what, Ariel?
1.
No, 3. It's still 1 times 3 times 1,
Okay.
right? So you still only have 3. Okay? Some teacher will say, oh, x power 1, I'll just take the number in front. Feel free to do that. It's just that I want to show you that it follows everything that you have seen so far. Everything that you have seen so far, the first, the second, then the third, it still remains the same here, okay, in this situation. I apologize for my third step. Yeah, it was wrong. Right? Now, I'll go a bit faster. I'm still not explaining the why. I will go faster because I want you to have this as a memory already. I want you to memorize this, have it as a habit. Just trust me for a while. Don't fight too much. Please don't fight this weird thing. Okay, I promise I'm not teaching you something weird or something useless, right? I promise I'm teaching you something that is core. Now, random number, please, Matthew.
5.
Oh, sorry. 5. Another random number.
10.
10. Right. Let's put it as 10. All right. Anu, please differentiate. So what do we do? The first thing.
Bring the 5x down.
Okay. And then?
10 minus 1.
Which is 9. And then?
And then times 10.
10. Apologies, not 9. 10. Okay. All right. And your final result will be 50x to the power of 9. Okay. Now, let's go a bit faster. Anu, random number, please.
8.
8. Okay. X to the power of?
3.
Okay. Minus 1 over 3. Okay. Ariel, differentiate this.
Okay.
The first thing that you do is?
Bring 8x like down.
Okay.
Yeah.
And then the second thing that you do?
Minus 1.
Minus. Your mic is not very good.
Oh, write down minus 1. Yeah.
Minus 4 over 3, is it? Sorry. And then you write down in front times.
Like minus 1.
Okay. And then the final answer will be? Minus 8 over 3 x to the power of minus 4 over 3. Okay, as weird as this sounds, this is correct. Okay. Now, Nicholas, random number, please.
7.
All right. Power of?
Negative 1 over 7.
All right. I'll just make it negative 8 for now. Okay, can ya? Okay, good. I'll put a negative here though, just to spice things up. All right. Differentiate this, please, Nicholas. First thing to do.
Negative 9 times negative 7.
Negative 9 times negative 7. What is that? Oh, yeah, you're already doing something very fancy, lah, right? I suppose, please don't do that. Please do the first, second, and third first. Please do that.
Second is minus 9.
Okay, and then you put the negative 9 in front. Okay, third one.
May I ask why just now
Mm-hmm.
you said in the first
I'm
one?
sorry. Negative 8. What am I talking about? Negative 8, negative.
No, why?
Because my third step, the first time I explained, is wrong. This one I apologize. I should be taking the original power and putting it there.
So you're saying every other time you did it was wrong, so I have to rewrite.
Yes. I
So
rewrite
the
this now.
2x 1/5 is supposed to be 1/5, not negative 4/x.
The in front one, yes, is supposed to be 1/5, not negative 4/5.
Oh. And then the first one should be 5.
Hey, Nicholas, I did everything already like just now.
Then why is it still 8?
This one is 5. This one is 1/5. And this one is negative 3. Would that be okay? All right. That was the original power.
Then shouldn't the answers be different?
This one is negative 8. Yeah, the answer should be different. Can we just focus on the 1, 2, 3? Okay, please practice this differentiation by yourself. And then after around 1 minute, I will write down the answer. Doesn't take long. Please do that by yourself. And then around the answers. All right, now time is up. I intentionally make this fast. I am trying to make you not think too much. I am trying to make you follow. Something very rare. It is rare. So I apologize when I make the mistake just now. You're following the wrong thing. I have to correct it again, right? But please follow, right? Anu, what's the answer for the first one?
4/5 x to the power of 3.
Which comes from 1/5 x to the power and then 3 minus 1 and then times 4. Okay, this is correct. If you're wrong, just correct it. If you're confused, do ask though. Okay, do ask. Okay, now, Nicholas, what is the answer for the second one? According to you, according to
It's negative 1/3 times negative 2x to the power of negative 1/13.
Okay, I'll call it as negative 4/3, not 1/3. It's way easier to manipulate that later. So now to finalize, this will be a positive 2/3 x to the power of minus 4/3. If you are wrong, do fix it. If you are confused, please ask. Okay. Eben, the last one.
6x minus to the power of negative 3.
Right, which is correct. Why? Because you're negative 3x, steady, negative 3, and then times negative 2. All this is correct. Great job. Okay, now at this point, if you have any confusion following, or if you feel this is very slow, please tell me. We are supposed to do this rather fast. The following part should feel easy, you see. The explanation will be hard later. Here, yeah. Now, I will now do the harder one. We went through a very hard pick just now, getting the habit. Now, I'm going through the second hard pick. Okay. Remember when I say to you, going down means differentiation, whatever that is. And then I go demonstrate all this weird stuff, okay, to you and ask you to trust me. Hey, that's differentiation. Thank you for trusting me. Now I'm going up. Going up means I'm doing a reverse of a differentiation. I'm doing an integration, right? So I'm going to demonstrate the first integration. Hey, the first thing I do is not very different. The 1/5 is still there. The x is still there. Because I am integrating I plus 1, I hope that makes some sense. I'm going to put 5. That is my second thing. Hey, I'm reversing it what? Right? That's a 5. And then I will also be putting something in front, right? That's the third thing, right? That's the third thing. My third thing may feel a bit weird, but this will be, okay, influenced by this guy, 1 over that guy. Now, one more time, I'm claiming that the integration result here is 1/5 times 1/5 x to the power 5, which becomes 1/25 x to the power 5. Okay, again, this will appear weird. Now, asking somebody's wisdom here, maybe Matthew. Matthew, your first time seeing integration, right?
Yeah.
What do you think is the best way to confirm that my integration is correct? You know very little about this thing. I'm asking you, what is the best thing you know to confirm that my integration is correct?
Differentiate it.
Fact. Why don't you try? Frankly speaking, that's the only thing you know, right? But if
Yeah.
my claim is correct, if my claim is integration is the reverse of differentiation, I can just differentiate it back and hopefully I get the original one. Correct or not, guys?
Yeah.
I challenge Matthew and everybody else. Differentiate my result. Do you guys get the original? Give you around 30 seconds to do so. In fact, all of you should be finished by now. Now, if any of you are confused, please tell me, correct or not? If I differentiate this guy, I will get, remember the rule of differentiation, 1/25x stays the same. 5 becomes power 4, and then times the original power times 5. This does become the original. My integration is correct. Because I differentiate back, I'm okay. Does this make any sense, guys? If this doesn't make sense, please ask your questions. Okay, so I hope I am teaching you something not so new. I am just saying I'm doing something a reverse. You can always confirm it by doing what you know. Okay, now I'm going to do that to the next two things just to demonstrate. Now, the next thing is the same thing lah, this thing. So what do I do when I integrate? I go up symbolically, minus 2x stays the same. This one becomes plus 2/3. Why? I plus 1. Last thing to do, 1/2/3. Please write that down. Please don't think, hey, what is 1/2/3? Never mind. Just write that down and let the calculator do for you or think about it later. Let me repeat this one more time. Do not let the fraction bother you. Who cares? Just write down 1/2/3 lah. You think later. That's important to do it correctly. Many people get very confused in exam just because they are forcing it too much. Now, with the help of your calculator, you will then discover that this is actually 1 over 2 over 3 times minus 2. You will discover that it will become minus 3. Let's just let the calculator do its job. How to confirm that this is correct? You just differentiate it back. Minus 3x stays the same. 2 over 3 minus 1 over 3. And then your 2 over 3 goes down here. When you let everything does its job, you do get the same thing. Okay, my process is the same. The fraction confuses us a little bit. If you cannot follow, please tell me. Right, I'm going to do the last. Minus 3x minus 2. I'm going to invite somebody to integrate with me. All right. Ariel, would you integrate with me, please? First step, second step, third step.
Oh, okay.
First step.
I'll write down like minus 3x.
Yeah, that stays the same. The power.
I'll move it to like the front.
It becomes.
Oh wait, no, like add 1.
Yeah, which becomes.
Minus 1.
That's great. And then this will influence the third step. 1 over what? 1 over minus 1. Say that. 1 over minus 1. That's it. That's it. Don't think too much. Think after this. Okay, now complete it for us. You can press your calculator. What is the final answer? The final answer would be
Or is 3x to the power of minus 1?
yeah. And even though you sound uncertain, we never actually stop here. What we always do the extra step of confirming, right? So please, we differentiate back. What is the first step?
Write down 3x.
And then the power.
Minus 1.
Come on, the power is?
Like minus 2.
Minus 2. And then the final step times?
Times minus 1.
Which does give you the original thing.
Yeah.
One more time, guys, I am integrating. I'm doing a reverse of differentiation. Of course, it feels weird. I'm teaching you something new and then I'm asking you to reverse. But that's the whole point of today. I'm teaching you to go back and forth so that you will never be confused. Never be confused after today. Right now, you're probably still confused. Okay, now guys, your challenge is to integrate. To integrate what? To integrate the result. Yes, Nicholas, yes.
I still cannot wrap my head around the second one. Why is it 1 over 2, 3?
Okay, right. So when integrating, the third step, right, is the third step that confuses you, correct or not? Okay.
Yeah.
How does the third step work? I'm not saying that it is easy to understand, but I'm saying the third step is, oh, I see a 5, right? I see a 5, I just automatically 1 over 5. That will work. Now, in the second situation, I see 2 over 3. Well, don't think too much. Just say 1 over that guy lah, because that's what we do. Something like that. Just say that.
Why? Why not just the same thing? Why
What
not just why not just 2 over 3? Why need to be 1
But
over?
I never did a 5 here. Remember, this is integration, man. Remember that this is integration. Integration is not differentiation. The reverse lah. In differentiation, I put the 5 immediately over there. So in integration, I put the reverse, which is 1 over.
So this is called integration.
Oh, this is integration. Because I'm going up, ma.
So the one on top is differentiation.
Again, one more time. When I go down is differentiation. When I go up is integration. That's the symbol. That's the informal direction.
And you go down is differentiation. So
Correct.
the negative, so the minus 1 is integration.
No, the minus 1 is differentiation. Going down is differentiation, remember? This one is differentiation, see?
So minus 1 is differentiation.
Correct. Plus 1 is integration. Confusion, but please get used to it.
So integration is going up,
Informally, going up is integration. Yes.
but that one isn't going up. It's 1/5. It's lower.
Yeah, because in differentiation, for whatever reason, it's 1/5 times 4, correct? That's the differentiation, correct? Times 4, right? So
Differentiation.
in integration, I have to reverse that process into 1/, instead of just multiplying it by. I hope that makes some sense. Okay. Again, in differentiation, I multiply. So in integration, so to speak, I divide 1 divided by 5, something like that.
So confusing.
I'm not saying that it's not confusing. I'm saying that please follow. It is confusing. I acknowledge that. Okay, and that's why we practice. No matter what, we have to get through this. Okay, and then things will get easier. That one I promise you, get through this, things get easier, not harder. But get this one thing right. Okay. Now, once you're ready, you are practicing integration and you will confirm for yourself whether the integration is correct by differentiating, right? So I'm just taking whatever is here, okay? I'm rewriting for you. Please integrate this guy and have the habit of writing up, so that you feel like you're integrating. Integrate this guy, again, moving up. And finally, integrate, okay, sorry, the last one. Okay, I'm going to do the last one. Okay, integrate this guy and I'll go by moving up. Okay, I'll give you 1 minute also. Feel free to feel as weird as possible, but stay and follow me. Stay and follow me. We'll take a break after this. Okay, almost done, guys. Whatever is the result, leave it be. Okay. We're not supposed to think too much. We're not supposed to do too long, right? We're supposed to practice the habit. Eben, first one.
1/150.
150 x to the power of.
X to 6.
Now, do us a favor and differentiate together. Differentiate for us.
Like the
Do the
process.
Yeah, do the steps.
Uh,
Write down 1/50 x, right? That one stays, correct? Okay, x to the power of
X to the power of 6.
minus 1. Minus 1.
Oh, minus 1.
5. And then what do you do? Third step.
Multiply
By
5.
6. By 6. By 6.
Oh,
Okay.
6.
Yeah. Okay. Again, you see what I'm doing, Eben? I am making sure you can integrate and differentiate without getting confused. Of course, we'll get confused. No, of course, we'll get confused. That's the whole point. I'm trying to get you to practice until it's not very confusing. Of course. Okay. I'm not trying to confuse you. I am presenting two things together, and after a while, you can do it back and forth. Okay. Now, if you do this correctly, the differentiation is that one, and therefore your integration is correct. That's the good news. Yeah, I'm adding additional burden, asking you to differentiate back everybody so that you're used to doing both side by side. With that, you'll be immune to certain things that will, happen later on. That's what I'm. Okay, Eben, congratulations. Your integration is correct. Okay. Okay. Good. Matthew, integrate.
The answer is -6/5 x to the 5/3.
Okay, and help us by differentiating it back. First step,
Um,
write down the
-6/5 x,
then power,
2/3,
and then times,
5/3.
which if you multiply nicely, it will become this again. And therefore your integration is correct. Do you understand, Matthew and everybody else?
Yes.
Good. You have now understood integration and differentiation, at least for this. Okay, Ariel, last one before I take a break. What do you think the result of this one is?
Wait, I don't know. I'm really confused.
This one is the most confusing one. I agree. You get this one. If nobody else is confused, every one of you is wrong. Maybe Ariel is correct. Ariel, try your best first though. Try your best.
Just like write 3x down and then like you add 1, so it becomes like
0, right?
so it becomes 0. Yeah.
Yeah. And then the problem comes with 1/0. Correct or not?
0. Yeah.
And this is a big question mark, which I am supposed to address after the break. If all of you have nice answers, then you are all wrong. This is supposed to be the most confusing part. Okay? Okay. Now, if you have any question, just keep it until the break. We'll take a 5-minute break. We do need it so much. Okay. If you do want to ask question right now, then feel free. My 5-minute break starts. Okay. Take a break, guys, and come back later. Yeah. Yeah. All right, guys, please confirm that you're here. Anu, are you here?
Yeah.
Right, Ariel, you're here. Great. Evan, Matthew, Nicholas.
Yeah.
Yeah, yeah.
Okay. All right.
Yeah.
Nicholas. Okay. Sorry, Nicholas, you're here. Yeah. Sorry. Oh, yeah. Okay.
Yes.
Right. Okay. Congratulations for following me with the integration and differentiation. I promise you there will be peaks, and I promise you the peaks will be over sooner or later. We went through the second peak just now, the integration, the first time you see. Okay, you fight against the habit, very weird. Congratulations for following. Okay. Come to the exceptions. The exceptions are supposed to be easier. It's not a peak. I'm now going to describe 3 exceptions. These exceptions does not follow what you did. So not all integration or differentiation is like this. However, I am saying that the exceptions are rather easy to recognize. So I'm going to introduce them at one go right now. The first thing you see here is this one, no? The integration of x power minus 1. The issue is this guy. The issue is this guy. Whenever you see power minus 1, you have encountered the exception in integration. I'm going to go to the next page. So this is now the exceptions. Currently, I'm not even helping you make nice notes. I'm just putting this into your mind. I'm just doing that right now. Okay, so x power minus 1. When you differentiate, remember going down informally differentiate is totally normal. Okay, it is what you have learned. One more time, what is this? You know, just write x and then this is minus 2 and this is power minus 1. This is totally normal. When you go up, it is an exception. What is this, right? It becomes with no explanation, okay? I'm not explaining this. I'm just saying. I'm sorry, I'm just saying. It is logarithm natural x. The weirdest thing
Teacher,
ever I could write.
I cannot read that word
I'm sorry.
on
This
the
one,
arrows.
I just
Is it?
yeah, I just erased that. Sorry, confusing. Nothing is there. I'm just saying integration, right? The arrow up is just integration. And the result of this integration is just logarithm natural x for no reason whatsoever, but I guarantee you that this is correct.
And what's the bottom one?
The bottom one is normal. That's just a normal differentiation, what you have been doing up to now. Yeah. What you have been doing up to now is differentiating in this way. That's normal. So therefore, if I integrate this, it will also be normal. I hope that makes some sense. If the differentiation is normal, the integration is normal, right? Now, in this case, the integration does not make any sense. This comes out of nowhere. Nowhere at all. Don't know why this is correct. This will be correct, but don't know where. The differentiation of logarithm natural x is also x to the power of minus 1. Don't know why, but this will be correct. This is the first exception. I'm gonna repeat this. Okay. Now, here's the question. Is this doing something normal or are we doing an exception? Okay. Ariel, I want to go up, meaning integration lah. Are we doing something normal here or are we supposed to do an exception?
Oh, wait. This is integration too.
Minus x power of minus 2. Normal or exception?
I think it's normal.
This should be normal. So
Yeah.
what is normal? Just write down minus x and then power.
Yeah.
Power.
Power minus 1.
And then, time.
Is 1
Yeah,
that's
which
all.
this becomes simply x to the power of -1. Some people like to call this 1 over x, whatever. This is normal, totally normal, okay? Totally normal. But I claim the integration after this is not normal, which is you just memorize. That's actually basically it. Please remember that if you do it normally, you call 1 over 0, right? So the normal method doesn't happen anyway, right? It doesn't work anyway. So please remember, I am telling you the answer is something very real.
Is it a minus?
I'm so sorry.
You said bracket 1 over -1, bracket minus x minus 1.
Yeah, correct. And in total, everything becomes plus lah. No, mate?
Okay,
Correct, right? You have to confirm
I
this.
saw wrongly.
The minuses will be confusing here. That's fair. That's fair. Okay. Thank you for asking. Clarification, very important. Now, back to the normal integration of 1 over x or x power y. Anyway, the normal method doesn't work. You have to at least see it doesn't work. Okay. So, Ariel, what did I say the answer will be?
Ln x.
And that's it. That's all. That's all I'm asking you to memorize. Ta-da! That's it.
Okay.
Matthew, what is the differentiation of logarithm x? Logarithm natural x, sorry.
What?
The differentiation of logarithm natural x. Ln x, ln x.
Oh,
Differentiation is nothing normal. Nothing normal. The differentiation is 1 over x.
yeah,
Can you accept that? Like nothing normal here. Totally new, totally weird. I understand. But do you understand what I'm saying, Matthew? That's the
Yeah.
differentiation. Okay, great. Now, for clarification purposes, integrating ln x is out of syllabus. Out of syllabus. Good news. You do not know the integration of logarithm natural x, nor do you want to know. It's out of syllabus. You like it, go to JC, take H2 math. Go to year 5 and take your H2 math. Ariel, that will be waiting for you in year 5, if that's your thing. Right? Right now, it is out of syllabus. Do not worry yourself about integration of logarithm x, natural x. Okay, all these are easy to say, but we gotta get it right. Okay.
So anything after
Logarithm
ln x
x
is our syllabus.
up lah, up, going up, going down, not really. So here's my
By the way,
next.
may I go toilet?
Hey Nicholas, you should go toilet on the break, leh.
I didn't feel like it.
Okay. Anu, which one is inside the syllabus? Going up or going down?
Going down.
And that would be?
X to the power of -1.
Yeah. Okay. How do we know this? Pure memorization. I'm so sorry. Okay. How do you know this? Pure memorization. Now, this is the first exception. Okay. I'm going to write down the second exceptions. The second exception is, this is not a peak. This is hopefully very easy to see. Sin x. Going down means differentiation. Now, sin x, you cannot use the normal method also, but it's not difficult. For some reason not explained to you, the differentiation is cosine x. I will continue differentiating. Minus sin x. Minus cosine x. And then here I put a dot, 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 and going up I put a dot, dot, dot. Now, what does dot, dot, dot mean? Very simple. It will repeat itself. Okay. Sine, cosine, minus cosine, and then you'll go back to sine, so to speak, dot, dot, dot. Here, you'll go back to minus cosine, dot, dot, dot. This is the pattern. It's a pattern. It's to be memorized. Nothing makes sense right now, but I hope it's kind of easy. Okay. Nicholas, are you back? Okay, memorize this pattern and I will just, test it out. Okay, what is the pattern for the second exception? So things that doesn't follow the normal method lah. This is regarding trigonometry. So Ariel, what is the pattern?
Sine x, cosine x, minus sine x, minus cosine x, and then it repeats.
Right. I'll just summarize it at this way. It's too easy to memorize even though you don't understand, right? Okay, Nicholas, are you back? Okay, one by one. Eben, the differentiation of cosine x, what is it? According to the pattern in your mind.
Negative sine
And the integration is?
equation sine x.
Yeah. Whether you know the reason or not, you are absolutely correct. Good. Nothing that difficult. Okay, Matthew, minus cosine x, differentiation and integration.
The differentiation is sine x
You'll be correct.
and integration is negative sine x.
You will be correct. You don't know why, but it's easy, right? That's why I told you it's not P. Okay. Nicholas, are you back? Oh dear, it's going to miss everything, right? Now, third exception. There are only 3 exceptions, so thankfully we're almost done. E to the power of x. We did that something like that just now. This is even easier to memorize. The integration is, and the differentiation is the exact same thing. And of course, it will repeat itself. This is super weird, but super interesting. In any case, this is the differentiation and integration of e power x. It is not that hard. Okay? Right. Anu, what is the differentiation of e power x?
E power x.
And the integration, therefore, is also e power x. Right? You have 3 exceptions. I'm going to write down the first exception again. Is something to do is x to the power of minus 1. Okay, Eben, do I write down logarithm natural x on top or on bottom?
On top.
There's an informal way of saying it, right? Then going up, no need to know.
Okay.
Going down, minus 1, x minus 2. Once you're good at the normal method, you can write down from left to right. Once you're good at it. When you're still learning, do what I say, first step, second step, third step. Okay, but after a while, you will get good at this. Okay, my purpose, ladies and gentlemen, is not to ask you to practice too much. Your teacher will ask you to do that. You will get enough practice just by following your teacher's homework. No matter how bad or how good your AMath teacher is, I have never encountered an AMath teacher who does not give you many practices in differentiation integration. You will get more than enough from them. I'm not going to give you that much. I'm giving you an overview. That way, when he talks, you understand, and you can do it very fast. That's my goal. That's what makes your secondary 4 stable. Okay, you will be able to follow the class very easily. Yeah, that will be my promise. Now, we are at these 3 exceptions. And then I am going to cover the 3 rules. These 3 rules is the last peak. There is a peak. This is the last peak. Okay, this is the last peak. So follow me. Nicholas, are you back? Okay, guys, it's not.
I'm back.
Okay, right. Okay, guys, it's not that we cannot go to the toilet, during the lesson. It's just that I don't want to keep everybody waiting. So therefore, there will be a recording. So Nicholas, if you feel that you missed something, you just look at the recording later. All right? Okay. You cannot concentrate if you want to go to toilet also, but let's not punish the rest for doing so. Now, let me write down what we have done so far. We have done normal things, right? We have done normal things. Random number, Nicholas.
6,
And then power.
1/3.
Okay, I'll put 1/3 here, and then I'll put a minus. We did a lot of normal things, but this should be a good representation of everything. I can go up, I can go down, right? X to the power of 6x minus 4/3, and then this is times minus 1/3. That's your differentiation. And then when we go up, this is still 6x. This is going to be plus 2/3, and this is going to be 1/2/3. And please note that it seems to not end. We can continue further, that is in the syllabus. We can continue downward, that is also in the syllabus. This is your normal thing. If you want to summarize what we did, this is a reasonably good summary. That's the normal. What are 3 exceptions? First exception. Logarithm x, go down, x to the power of -1. Going up here, not needed. Going down here, do we stop or can we continue, Matthew? Can we continue or not? Going down?
Yes.
Yes, and then just put a dot just to indicate. This one not needed outside the syllabus. Second exception, what is it, Anu?
It's the sine x and then go down.
Correct. Now just write the pattern like this, can? Dot. Easy to remember. What is the third exception, Ariel?
It's the E one.
E to the power of
X.
x. Go up, go down, the same thing, and then therefore dot and dot. Okay. This is what we have been covering. Okay. If this feels reasonable to your mind right now, good job. You went through 2 peaks. I'm giving you the third one right now. Now, there are 3 additional rules, and that's it. Yeah. 3 rules for differentiation. No rules at all for integration. Sounds like a good idea. Sounds like a good news until we realize later. Therefore, integration will be the harder one, and differentiation will be the certain one. At this point, this is the point where differentiation officially becomes the easier one because it is certainly doable. Anything is doable with the 3 rules. Integration is a totally different thing. There are no rules to help. Therefore, it is harder or sometimes impossible. This is where integration differs from differentiation. Before this, they are about the same. Before this. Let me now present you the 3 rules of differentiation. Remember, there is no counter rule for integration. Okay, again, I'll show you the effect later. Okay, we have half an hour. Go through me this peak and you will, well, you'll be complete lah. Right. Okay, they call it, I don't know, they call it product rule. Okay, easy. It has something to do with times. Product ma. They call it quotient rule. I would prefer to remember it as the division rule, something to do with division. Product rule, quotient rule, and then chain rule. Whatever this chain rule means, I would prefer to call it the onion rule. Onion rule, something inside something. Onion always have layers, all right? These 3 rules help us do everything regarding differentiation. Let me demonstrate the first one, okay? Now I see x squared times sine x. Okay, x squared times sine x. Please try. You don't know anything. I understand you do not know exactly what is happening, but just try, okay? Just try. Please, somebody, would you volunteer to differentiate? Anybody? Who is the courageous person? Any volunteers?
X to the power of 1.
X to the power of 1, sure.
Cosine X. That's cosine.
Right, with the times here, right? I see that you're trying to do the normal and the exception. Anu, I think you're forgetting the 2. Am I correct, Anu?
Oh,
You
sorry.
seem to be forgetting the 2, right? If you want to do it normally, then at least do 2 lah. Make sense? Right? Now, time for me to use GeoGebra and convince you and everybody else that this is not exactly correct. Okay? This is not the peak yet. This is just me showing that it is correct. Okay?
Wait, teacher.
Yes?
What does that say? The chain rule?
Chain rule. Whatever that means, I haven't introduced that. I will call it the onion rule. Whatever chain rule means, you will hopefully get it by today, hopefully. It's called chain rule, but no need to write down yet. No need. Okay, I'm just saying the names of the 3 rules. Okay, I'm not even introducing it right now. I'm just saying that, hey, what Anu did, thank you for being courageous, might not be correct for whatever reason. I'm going to GeoGebra right now. So GeoGebra, very convenient, right? Look at that. Sin X, the differentiation, those are the formal writing. I've never teach you the formal writing, G prime F, whatever, who cares? Look, the differentiation of sin X is cosine X, what you learned just now, correct? Okay, let me just show you. I claim the differentiation of minus sin X is minus cosine. So let me do that. Minus, and then here they just adjust by themselves, right? Minus sin is minus cosine. Nice, right? If I change that to cosine, you know, for clarity purposes, cosine x, and it will nicely change to minus sine x. Your memorization is fine, right? I'm going to delete the derivatives one for now. Never mind that for now. Okay, great. Okay, now, also look at the first one, just to convince you that you are correct. Okay. Matthew, what is the differentiation of x cubed? Write down
X
x power 2 times,
times 3.
which is, can you see that, Matthew, everybody else? The differentiation of x cubed is 3x squared. Can you see that in GeoGebra? Okay. Yeah. Now, what is the differentiation of minus 2x squared, Nicholas?
Okay, repeat that.
The minus 2x squared, which is this guy, this guy. Minus 2x squared, this guy.
Okay. What?
The differentiation of that will be?
The what of that? Wait, the what of that?
The differentiation, the differentiation.
Oh. 2 times minus 2x1 minus
Yes.
4x.
Which is, hey, you and GeoGebra are in agreement, correct?
Yeah.
You and GeoGebra, good. And so hopefully everybody else. Okay, Ariel, what is the differentiation of 5x?
Oh, right. That one is like the differentiation is the go down one, right?
Yeah, the go down one, whatever that means, yes.
Okay.
Write down 5x, right? 5x,
Yeah,
and
5x.
then power 0, right?
Power 0. Yeah.
Times 1.
So it's
So
just
what is that?
so it's just 5.
5. And you and GeoGebra are in agreement, correct?
Mm-hmm.
I didn't do this, okay? GeoGebra did that. Now, for the sake of clarity, minus 1 differentiated becomes 0. It becomes nothing. Whatever number, okay? 1,000 without an x, okay? 1,000 differentiated, 0. Okay? Anu, what is the differentiation of 3 million? The differentiation of 3 million is?
0.
0. Thank you very much, right? Now, you can see that for some reason, you and GeoGebra are in agreement using the normal one and also using the exception. Okay, hopefully that's a good thing. GeoGebra can also handle complicated stuff, right? For example, we'll throw him all the complicated things that you have done. Sorry. Where is the fraction? I cannot even find the fraction here, right? 1 divided by 3. I'm so sorry. 1 divided by 3. Okay, 1 over 3 x to the power of, okay, minus 2 divided by 3, right? That will be, the name will be H. Remember, just press 2 buttons. This one, and then press the letter H. There you go. Okay. As weird as this, oh my goodness, the GeoGebra kind of does it a bit weird. Oh my goodness, GeoGebra cannot handle this. Oh wow, that's so weird. So GeoGebra does have a weakness, isn't it? Okay, I'm gonna cancel that first, right? I'm gonna cancel that. Right. Okay, now back to what I'm supposed to show you. Sorry, yeah, I was sidetracked just now. Right. I was trying to show you x squared times sine x, okay? I was trying to show you x squared times sine x. Sorry, yeah, I was sidetracked. Okay, now we have x squared times sine x. There you go. And GeoGebra decided to call that H, and the graph looks something weird like that. So whatever that is, right? X squared times sine x. Now, what is the differentiation of that? Press 2 button. Now, for some reason, this doesn't seem to be what Anu mentioned. So Anu, do you still remember what you said? The differentiation of x squared times sine x.
I said 2x to the power of 1
Times the power of 1, okay, and then times?
times cosine x.
Right, sine, then you will say x here, right? Now, just to be clear, what Anu say makes some sense, but it is different from what GeoGebra is saying. GeoGebra is saying something more complicated, and for your information, I agree with GeoGebra. He didn't do a mistake, okay? He didn't do a mistake. So what's going on here? I hope you will notice that certain parts of what Anu mentioned is there. This is 2x. This is not 2 times. Huh? Your 2x is there. And your cosine x is also here. What happened is that GeoGebra follow simple rules that do make it correct. Okay, now going back. So now, according to GeoGebra, this is wrong. So you should be following the rule. Now, the rule is product rule. Why? Because there is a times. Up to now, we haven't been dealing with times at all. All the normal and the exceptions are basic stuff. They don't have any multiplication in there. But certainly, it is very easy to introduce multiplication. So product rule comes in. Something that you memorize. It's not that difficult. Okay, what does prime mean? Trying to introduce something formal. The u primes means the differentiation of u, right? This means that I differentiate u. This one, I differentiate v. Now, who is u and who is v? Considering that product rule is multiplication, that means there is somebody multiplied by somebody else. So we will call this our u, and we will call this our v. As weird as it sounds, I have to follow the rule to be correct. This is wrong. How do I follow the rule? Very simple. At the start, please do it one by one. The differentiation of u, write it down. The differentiation of v, write it down. It's actually very easy. Nicholas, what is the differentiation of u, which is 2x squared, which is x squared?
The differentiation
Of
of
x
u.
squared is? Come on, write down x, write down power.
Wait,
power 1 and then times
Okay.
2. Okay, we're going through in your mind the steps. Write down what stays, write down the power, write down the guy in front. Okay, 2x. What is
Wait, what are you writing?
I'm writing here. This is
How
our
is
u.
U 2x?
U is not 2x. U is x squared.
And why you write 2x?
Because u prime is the differential of u. Sometimes I think that you don't follow.
Prime.
Yeah, one more time. This is the formal writing. This is my first time introducing the formal writing. If they want you to write down, hey, the differentiation of u, just put a prime there, and therefore that is the differentiation of u. That's just a formal way of writing it. That's not
Oh,
one.
okay.
So this prime is very, very weird. This is not power 1 at all. This is not number 1 at all. This is u prime. I'll show you in the GeoGebra. Look, the prime over here there, that's the prime. That's not power 1, okay? That's their formal way of doing it. Okay, so again, that is the notation for differentiation. So for example, I want to differentiate it one more time. I just write down u double prime. That's double differentiation. In that case, that will be number 2. That's the formal notation. If you're very confused, please tell me right now. Okay, sorry, yeah, formal notation. Sorry, formal notation. Okay.
Let me write it down first.
Yes, please. Yes, please. I'll go slow. Okay, this is not peak, but I'll go slow. Eben, what is the differentiation of v? V is sine x here.
Sorry, what was the differentiation of
Sine x there, sine x.
just cosine x?
Yeah, that's correct.
Oh,
Just for
okay.
practice, if I differentiate one more time, v double prime, right? I just go and differentiate further. That's the formal notation. What will it be, Evan?
The negative sign x.
That's negative sine x. We don't need this just for practice, okay? That's just practicing the notation. So good job. Now, why are we preparing our u prime and v prime? Because the rules say so. There's a lot of I say so. I apologize. I rarely say follow me, okay? But in this topic, we have to go through quite a lot of follow me, just follow me, okay? So following the rule, you will be correct. You have to write down u prime times v plus u times v prime. It's not that difficult to memorize. U prime v, u v prime. U prime v, u v prime. So what is u prime v? The differentiation is 2x times sine x plus u, which is x squared times v prime, which is cosine x. I am just following the rule. Is this kind of okay so far, guys? Now, you will notice that this will be what GeoGebra's, I should. You will notice that this is what GeoGebra say lah. That's it, 2x times sine x, x squared times cosine x, right? There you go. Okay. I'm so sorry, I'm not very good at making it side by side. Okay, so GeoGebra and I are just following the rules. It is not very difficult. Okay, the rule is u prime v times uv prime. I'm going to go there. U prime v plus uv prime for something to do with multiplication.
Teacher, I'm not done.
Okay, we're going to practice it. Just nice, Nicholas. We're going to practice the product rule, okay?
I'm not done. I'm not.
Okay.
You can't finish writing. Almost done.
Okay. We're just going to practice it together. I'm still doing the same thing. Don't worry, yeah? Don't worry, because I know that this is new, okay? So we're going to practice it together. Okay. Ariel, random function, please.
function as it.
Whatever x, whatever,
Okay. For 7x
7x.
minus 2.
Okay, power minus 2. Okay, sure. All right, power minus 2. Okay, we have to do a function which is times something lah, because we are practicing product rule. Okay, so Ariel, would you please provide us with something else times what?
Times 8x to the power of 2/3.
2/3. Okay. Now, here's a very good example from Ariel. Thank you. My question to everybody is, do we use product rule or not? Do we use product rule or not? Think about it for 5 seconds. Anu, do we use product rule or not?
I don't think we need product rule for that.
Why not? Hey, there's a multiplication there. Why not?
But it just times it, right?
Okay, Anu suggests we do not use product rule. I'm up to it as long as the reasons are correct. What are you trying to say, Anu? Please tell us again.
We can just times it, right?
Go ahead. Go ahead. Do it for us. So the answer will be, sorry, the whatever you're trying to do, that will be.
Not sure.
Okay, come on. Right, okay. So Anu is suggesting to combine them. Anu is suggesting that. Am I correct, Anu? That's what you're suggesting.
Yeah.
Okay, and we need your indice to do this. If your indice is not strong, well, this is a good motivation to make it stronger. These are still basic indices lah. So we should be able to do it. Okay. Basic indices, right? So I'm combining them. There will be 56x to the power of minus 4/3. If you are confused, well, I suppose, tell me lah. I suppose. Is this okay? Okay. Now, let's assume that everybody can follow in this part. There wasn't a differentiation just now. Okay. Anu is suggesting something interesting. Let's not do product rule. Let's just differentiate this guy. Okay. And of course, we can differentiate this guy. 56x per step. Minus 7/3, step number 2. Times minus 4/3, step number 3. That will be the y prime lah. Remember, y prime is the differentiation of y. Okay. So far, does anybody understand? Is it okay? Is this okay? Now, this is the situation where, oh, I can do without product rule. Okay. I think that's better. I think that saves a lot of human error. There's a lot of human error in doing all this, no matter how good you are. I think this is a slightly better way than to use product rule. Now, of course, there are situations where you just cannot avoid it, right? The situation is when you combine this with trigonometry lah. So sin x, for example. Now you can no longer avoid this. Sorry, I make this as cosine x. You can no longer avoid this. As a result, you must do your product rule. Let me demonstrate one more time. Define for yourself who is the u and who is the v. Do the u prime, do the v prime separately. Okay, Matthew, u prime, please.
7x to the power of -3.
Right. And then
times -2.
Right. So whatever the result is, you will be correct. Okay. V prime. Nicholas, the differentiation of cosine x is?
Sine.
No. Sine, cosine, minus sine, minus cosine. You just remember that. The differentiation of V prime is? Remember the pattern, size, something like that. Of course, you don't know why is correct, but the pattern is easy.
Minus sine.
Yeah, minus sign. Okay. Why? Don't know, but easy to remember. Okay, let's just take it
Okay.
that way. Okay, let's just take it that way. If it is easy, we take it. Okay. So now the U prime should follow the product rule. Okay. Eben, please read for us the product rule. Just read for us.
U prime times V plus U times V prime.
Which, please do it for us. What will it be?
Negative 14x to the power of negative 3
Okay. Times.
times negative sine x. Wait, sorry. Cosine, yeah,
Very good.
cosine x.
Yeah. Okay. Don't know why, but you're
Okay.
at least following correctly. Okay. You don't know why this is correct, but you're following. Then?
And then 7x to the power of negative 2. Negative sine x.
Right. And voila, you have done your first product rule. Congratulations. This will be correct. And do you need to simplify? That's a matter for later consideration. Yes, yeah, sometimes you need to simplify, but this is the product rule. And if you do this, you will be correct. Any questions so far?
I don't understand anything.
Yeah, you mean you don't understand the U prime or V prime? Is that what you're saying?
Yeah.
Do you understand that we want to differentiate this first? That is what we're trying to do.
Yeah, I understand that until like the part where there's like costs or whatever.
Okay, first thing first, we're trying to differentiate something with a multiplication, which means things are more complicated. How do we know? That's why there's a product rule. That's the simplest question.
Oh, so it's like you just multiply it?
No, whenever there's a multiplication, well, if you can multiply, you do that. Because when you multiply, it becomes, well, no longer a multiplication. Hey, there's no multiplication here. Right? Nice lah. You do normal things, correct?
Okay.
But if you cannot simplify, look at the second situation. How can I simplify 7x power minus 2 with cosine x? I can't. And that is their intention. They're trying to give you something that you cannot simply, get rid of. I hope that makes some sense, right?
So when that happens, then you use product rule.
Product rule. And that's it. That's it. That's the additional thing. And product rule looks like U primary plus U B prime. It's actually doable after a while. Nothing complicated. That's all. That's all.
Okay.
One more time, the multiplication demands you to not simply differentiate one by one. You cannot. You have to follow a rule which is more complicated but correct. That is all I'm trying to say. Usually, that's what the teacher tried to say also. Just do it, man. Just do it, man. Okay? For now, that's it. For now, that's it. Okay, we have some time. I'll introduce the quotient rule. Well, quotient rule is for, well, division, some rule for multiplication, some rule for division, right? So now I'm going to repeat the same thing. This is 7x minus 2 divided by, right? What is divided? Divided by 8x power 2 over 3. Okay, and the second guy is 7x minus 2 over cosine x. And then I'll give you the quotient rule, the rule for division. The quotient rule is the U y prime. It will be something very weird, but you just memorize over b squared. This is troublesome. This is prime. And this is actually a real square. Very troublesome. The notation are very troublesome, right? Apologies for that. Now, for the first situation, do we product rule or do we quotient rule or not, Anu?
No need.
Instead, what do we do? Can you do it? Instead, we do in this lah, but can you?
Yeah.
Okay, then tell me.
7x.
7 over 8 lah. What do you think? Then x. And then?
Minus 2 minus 2 over 3. Yeah.
Correct. Which if you simplify will be 7 over 8 x to the power of minus 8 over 3 lah. Right? And then this differentiate just normally lah. Okay, we're not going to do that, but the differentiation will be normal. Great. Avoiding quotient rule is a good idea. Look at how complicated this is. Avoid it if you can. That's my lesson. If you cannot, then you use it low. Too bad low. If you can, please avoid. Okay, in the second situation, just to confirm, Eben, can we avoid the quotient rule?
Mm.
Can or not?
No, cannot.
Okay, so at the risk of making the obvious, let's repeat one more time. What is the u prime?
Was it 14x?
Yeah, 7x power minus 3 times minus 2. Remember the 3 steps, right? It's
Okay.
negative 14. It's good to
Oh,
go
yeah.
through steps. Right? And then the v prime is?
Prime is negative sine x.
Right. Now, Nicholas, you have the honor of assembling the quotient rule for the first time for all of us. Follow the ruler, u prime v minus u v prime over v squared. Such a long rule. Okay, assemble for us, please, Nicholas. The first thing to write is?
Minus 14x minus 3
Good. Very good. And then second thing to write?
cos x
Very good, because this is the v and this is the u, right? And then minus. Don't know why, but
7x minus 2
yeah, correct. And then
minus sin x
yeah, correct. And then
cos x squared.
cos x squared, which is usually rewritten as cosine square x. That adds to the confusion of the notation of math. But yeah. Do you need to simplify this? Yes, but simplifying this is no longer a differentiation problem. It's an algebra problem. Most of the time, hear me out, your problem will be simplifying this, which is not a differentiation problem. You already get 2 marks by writing this. That's a good news. But to get the complete marks, you usually have to make it nicer. That gives you a lot of trouble, but that is not what we're covering today. You should just cover it in your practice in school, and I will make sure that you can do it before exam. Okay, now, Nicholas, thank you. For the first time doing quotient rule, it's really not that bad. Right? We just have to, follow lah. Let's memorize the product rule. Product rule is u v prime plus u v prime. U prime v, sorry, guys. U prime v plus u v prime. The quotient rule, u prime v, same thing, minus u v prime, same thing, over v squared. It's not that bad lah. They won't give you, please memorize. Give you half a minute to memorize. Hey, I'm typing half a minute. I don't know. Okay, a very quick half a minute is done. Matthew, what is a product rule?
U prime times v plus uv prime.
Thank you very much. It's not that hard. Quotient rule. Nicholas.
Yeah.
What is the rule?
U prime v minus uv prime over v2
No, v squared. Yeah, just say v squared.
square.
Okay, hey, it's not that bad. It's not that bad, people. That's what I'm trying to say. It's not that bad. Okay. These two rules are okay, but it's okay. It's okay. The hardest rule I will just introduce. Yeah, Nicholas, please. Okay, I'm gonna mute you, Nicholas. Sorry. Okay, the last rule, we don't have time. I'll just introduce. The last rule is the last pick. The last rule, if you get it, your differentiation is done. All that remains is to see the questions. Thank you for following me. We will spend, never mind, it's already 9 o'clock. You know what? Never mind. We have one more rule and we will continue next week. What is cheap? No. Thank you for going through this hard part. I promise you the next part is, well, not easier, but at least you don't have to follow me too much already. You will be making much more sense. Okay, thank you very much. I will give you the recording if you want to. And that's it for today. Okay, whoever is coming for tomorrow, I will see you tomorrow. Bye,
Thank you.
guys. Okay.
Thank you.
Okay, well.